Hey, this is Math 8, Unit 6, Lesson 7, Observing More Patterns in Scatter Plots. So first we have in Activity 1, it says Notice and Wonder, Nonlinear Scatter Plot. What do you notice and what do you wonder about this scatter plot right here? So there might be some different things you notice. Of course, we can see first of our labels here. We have oil production down here by the thousands of tons, and we can see we have 250,000 all the way up to 450,000 of the tons of oil being produced. That means tons of oil being made. And over here we have crude oil import price. This is the dollars per barrel. So we're looking at a price over here and the amount of oil. So as oil production increases this way, that's the increase going that direction, what seems to happen to our price per barrel? Right? The barrel price over here, when there's only 250,000, is pretty high. But once you get over here, actually once you get about here, once you reach a certain spot, it looks like, and you have enough oil, the price seems to level out. So what's interesting about this is you see right around here, you might be able to draw a line there, but that doesn't fit with what's over here. This is a whole different kind of line, right? It's not even a line. There's a curved segment. It kind of curves and then kind of plateaus there. It just tapers off and becomes like nothing. So we probably wouldn't say this has a linear relationship because it's not a line. It's hard to say what it is, but there certainly seems to be a place about 300,000 tons of oil where suddenly the price for oil just stays pretty flat and doesn't get much more above $20 per barrel. So when there's less oil, the price is higher. When there's more oil, the price is pretty low. So that's some things we notice and wonder about this, but it's definitely not a line. We could say there's a negative association, right? And the reason we would say there's a negative association is because oil production, as it increases, the price decreases. So it has a downward slope for sure. Even though it's not a straight line, it'd still be a negative association for how these two things are connected to each other. Alright, let's move on to activity number 2. Okay, so activity number 2. Alright, it says a scatter plot city. It says your teacher's going to give you a set of cards. Each card will show a scatter plot. What you're going to do is sort the cards into categories. Okay, sort the cards into categories and describe each category. Okay, so that's what we're going to be looking at right here. So we're going to make categories, and then number 2 says explain the reasoning behind your category. So why you pick the categories you did, and your partner's going to have theirs as well. And then it says to sort the cards into 2 categories: positive association and negative associations. Now, just to let you know, you're also going to have like no associations, okay? Because some may not have associations at all. They may not make any sense. And then finally, sort the cards into 2 categories of linear associations and nonlinear associations. So let's take a look at what we have here. So first of all, we can see, and I'm going to just use my phone here, we have the card A. I'm going to see if I can turn it sideways here, and let's zoom in this way so we make it as big as possible. Whoops, too far. Make it bigger. Sorry about that. Well, sure, I can do 2 at a time. We'll just do that. So let's take a look at A to start off with. Hopefully you can see that there. Hard to tell. I think you're okay. And so for A, do we have in this case here, we can see the curve goes this way, and we have a kind of a crazy curve like that. I don't know what that is. We can see we have whole numbers here, 2, 4, 6, 8, 10, 12, and 0 to 60. When I compare that to B, B is also 0 to 12 there, and 0 to 60 there. A doesn't seem to fit any sort of positive or negative, and I'm going to look at all these things at one time, okay, just because it's just easier to do it on my phone like this. It's not positive and it's not negative. It kind of goes positive then negative, so it doesn't really fit a pattern. I'm going to say there's no association for those there for A, and it's not linear, so I wouldn't put it with a linear section here, but I'd probably say that this is A is a non-linear one. So that's kind of how I look at A being. For B, B seems to be, in this case here, it does kind of go this direction and then just drop off there a little bit. But it definitely is a negative association because it has a downward slope there. So I'd put B over here as being a negative association. In terms of if it's linear or not, because it starts here and then curves down and not just a straight line, this little part here messes it up. So we would also say it's a non-linear, because this doesn't follow a line. If you start here, there's not one straight line you can put through the whole group of data points. So I would say this is a non-linear one as well. All right, let's take a look at C. We'll scroll up here. So C, we can see we have the data clustered up here and then moving down this direction. So we would definitely, based upon this line, we would say that's a negative association there. And you could draw a line right through there if you chose to. So that's a negative association for C. And because you could draw a line right through the middle and most of the data points would be near that line, we would probably say this is a good example of a linear association. Just keep in mind, linear doesn't mean it needs to be perfectly like in a straight line. It's not going to be that way. But you could make a line where most of the dots are going to fit around that line. And that's what we refer to as a linear. For D, we see we start here and then we tend to go down. So again, we're dropping down this way, but it's a curve. So we would say because it's decreasing as this increases and this one decreases, this is going to be a negative association, that's for sure. So we can put D right here. But we would probably not say this is linear because again, we're dropping down and curving and then flattening out. So I'd put this in the non-linear category as well. The difference about this one here is that this one actually has some decimals. So maybe when you did some category sorting, you put decimals and this one didn't have, the rest had whole numbers. This one goes 0 to 80, just like A and B went 0 to 60. This went 0 to 80, but D is definitely with decimals. So maybe a category you used was whole numbers versus decimals. Okay, those are some things you might have come up with there. All right. Let's look at E and F. Now E is a great example of what we would probably say is a linear scatter plot. It sure does seem to fit inside a nice line right there, doesn't it? And does this line move in a negative direction or a positive direction? We would say this is a negative association again. So we're going to put the E with a negative and we're going to put the E with a linear over here as well. For F, F just kind of goes straight across this way and then woo, it curves up suddenly a little bit more. That's kind of an outlier probably, but it curves this way and we move on up. So F is definitely moving up, not quickly, but it does move up and increases as the value down here increases, the value on our Y also increases. So F is going to be our first positive, although it's not a fantastic positive, but it would go there. And again, because it goes in a line and then curves up, this would be a nonlinear association as well. A couple more. So here's G. G goes up and then flattens out there. So this looks more positive in its shape. I'll put that in the positive section. And is it a line? Well, if it stopped right here, it'd be a line, but because it goes up and curves, this is nonlinear as well. And H looks a whole lot like A except flipped around. It goes down, it flattens up, and it goes back up. So we got down, flat, up. So this is not going to be positive or negative because it does both. So we'll put that in the no real association category. Oh, not F, it's H. Sorry about that. That's H. Put that right there. And we would say it is not linear, it's nonlinear, so it goes in this category right there. Alright, and those are all of our cards that you would look at. So that's probably the groupings you would do with your partner again. Hopefully you did that on your own first before you watched me do it all for you. And that's kind of how that works there. What you came up with here for your categories and your explanation, that really is up to you. And then we just showed how that would work with the positive and negative associations as well as the linear and nonlinear associations. All right, let's move to activity number 3. In activity 3, it says, how are these scatter plots alike and how are they different? So how are these things alike and how are they different? Okay, well, let's see here. What do we notice about the different scatter plots that we see? When I look at A seems to have a negative association. B has a positive, but it actually looks like it almost has like 2. I don't know if you can have 2, but it looks like it has 2. C has both a positive and then a negative. That's kind of weird. And D, although there's a gap right here, does seem to be having a negative association there. So a couple things we might notice. We could say that A and D have a negative association from what we can tell. Okay. Another thing we might notice here is that D has a gap in the information. That's a little weird there. So that's different. And B and C, looking here, they're alike because they have two lines of fit. And I don't know how that's possible right now, but they both have two lines of fit, right? This has two positive, this has positive and negative. Kind of strange. Okay. For B, in terms of it being different, the two lines have about the same slope. They're pretty close to each other, not too far off, pretty similar there. For C, it has two lines with different slopes. One's being positive and one's negative, so that's different about that one there. Okay, so those are some things you might notice about how they're alike and how they're different. Now, what we want you to notice here is that because of some of these weird differences here, when there's more than one pattern, okay, when there's more than one pattern, we call that clustering. Okay, and so we can see here that in this case there's a pattern here and a pattern here. It's clustering. Here we have a pattern of positive, a pattern of negative. That's clustering. For this one, because of this gap, it's almost like you have a pattern over here and a pattern over there. So this is an example of clustering. What it does is it reveals to us some hidden patterns that you might not have expected, or what we might want to call subgroups within the whole group. So let's say, for example, you were in your classroom and you were checking to see height of boys and heights of students, right? And so you're measuring heights of students based upon maybe their age or their birth month or whatever it might be. You might end up with maybe a group of taller kids compared to a group of shorter kids, depending perhaps on when you did that, right? When you're in elementary school, you might have found that most kids in your class were similar height, and so you might get a pattern that looked pretty linear. But with time, sometimes when you look at a regular high school classroom, for example, oftentimes the boys tend to be a little taller than the girls in the class. That's not a good thing or bad thing, it's just something that you observe. And so if you were to make a scatter plot of heights of all the students in your class, you might find a cluster of boy heights that might be a little higher than a cluster of girl heights based upon ages and things like that. So it shows some other information inside of the whole data that you might not have expected. So that's what clustering tends to do. All right, and so you'll see some examples of that a little bit on your homework as well. Let's take a look at your summary. Summary today says, sometimes a scatter plot shows an association that is not linear. Sometimes that happens, right? So this one here, not linear. It's a nice happy face. Have a nice day. All right. We call such an association nonlinear association. In later grades, you'll study functions that can be models for nonlinear associations. We'll see how you can model those out later on, but not right now. And sometimes in a scatter plot, you can see separate groups of points. We call these groups clusters. And so these are the two clusters there, like we saw in our examples as well. So there's a couple new terms for you today: nonlinear association and clusters. So that's it for the lesson part. Let's pause there, let you do your homework, and we'll come back and check it together in just a few minutes. All right, here we go with our homework for Math 8, Unit 6, Lesson 7. It says literacy rate and population for 12 countries with more than 100 million people are shown in the scatter plot. Circle any cluster data. So literacy rate is how well people read and write in their country, okay, based upon population data. So we want to circle any clusters in the data. Well, we have a cluster up here and a cluster down here. We wouldn't call that a cluster because there's single values right there. But we do have these little strange little clusters here, which means there's a subgroup inside of the whole group, right? A lot of folks are up here, but then there's another group that's down here for whatever reason. That's just what the data shows for 12 different countries. Can't tell you much more than that, except that 12 countries, there's some here and some there. Number 2, here's a scatter plot. Yay! Select all the following that describe the association in the scatter plot. Looking at this one here, we can almost draw a line of fit right about there, right? So we describe this as a linear association. Well, it sure does look like it makes a line, so I'm going to go with yes, which means we're not going to pick nonlinear. Positive, positive association means that as the age increases, the weight increases. Is that true? Yep. As this goes up, this also goes up, and that's a positive association. True, which means it's not a negative, and it also means it's not a no association. So that's what we would say for number 2. All right, number 3. Next page. For the same data, 2 different models are graphed. Which model more closely matches the data? Explain your reasoning. So this is the same data points, but the model we're looking at here, in terms of the model, we're describing the line that is right here. Which line is a better fit, is a line of fit for the data that's given? In order to decide that, we need to see which one is more in the middle of all the points. When you look here, this seems to divide the points pretty evenly, some above, some below. On this one, you notice most of the points are above, with very few following below. So the one that has the model most in the middle of all the data points is going to be choice A. And now for you, make sure, just to make a note here, make sure you explain your reasoning. I'm talking about it. You need to do more than just circle. Number 4. Here's a scatter plot for data for some of the tallest mountains on Earth. The heights in meters and year of first recorded ascent is shown. Mount Everest is the tallest mountain in this set of data. Okay, so we have the first ascent down here and the height in meters. Estimate the height of Mount Everest. Well, this is the height, so which one's the tallest? That's this guy right here. So if we had to estimate the height, we could draw a line straight across this way. And what we notice is that the difference between 8,800 and 9,000 is a difference of 200, which means that that would be about 8,900 right about there. So we're about halfway there. So we would say about 8,850 is a good estimate there, because this number right here is 8,900, and we're about maybe halfway between that and that. So let's just say about 8,850 meters. That's an estimate. Again, it's just an estimate. Estimate the year of the first recorded ascent of Mount Everest. So now we go this way, and we'll draw a line straight down there. Oops, curve a little bit. And we end up here. So we're not, I kind of curved too much. I should be a little closer over here. We're closer to 1950 than 1960, so maybe about 1953. We're not quite in the middle. We're right about here based upon where it is in this box. My line got curved. Sorry about that. So maybe 1953, 1952, something along there would be good. So if you said 52, that would be okay too. It's somewhere around there. And number 5, it says a cone has a volume V, radius r, and height of 12. So remember, our cone has a volume of V, which goes with the 1/3 pi r squared h. And we know that the h is 12, the radius squared, and pi, and 1/3, and then all equals V. That's what we know so far. Right? Now, 12 times 1/3 is equal to what? 4. So 4 pi r squared is the value of V. That's exciting. Now the cone has the same, a cone has the same height, which is 12, and 1/3 of the radius of the original cone. So we're looking at the radius here. So this part all stays the same. What changes is the radius. So instead of radius squared, we would have the volume is going to be equal to 4 pi times 1/3 of the radius squared. So in comparison here, the big thing that's going to change is 1/3 is going to be squared. Okay, so 1/3 squared means I have 1/9. So this becomes 1/9. 1/3 times 1/3 is 1/9. So what remains the same from the cone volume is the 4 pi is the same, and the radius squared is the same. But what's different is the 1/3 squared. So what we could do is this, and this is where it's a little tricky, so it's going to talk this through here. The volume of the cone, okay, that has 1/3 of the radius is the same volume of this cone, but it's all going to be divided by 9 or multiplied by 1/9. So why is this the case? Why is that going to be our solution? Because our volume stays the same. This doesn't change. Our volume is exactly what it is, but we're going to do 1/3 of the radius squared. So we do 1/3 squared, which is 1/9. All right, that's the idea for that one right there. I'm not sure. Is there one more to go? Let me look on the back side. Yes, there is. So if we know volume is what it is, now if the cone has the same height and 3 times the radius, well, what are we doing in the radius? The radius is being squared. So when we do 3 squared is 9. So the same idea is that whatever the volume was of the first one, it's still going to be all those numbers, but now we're going to multiply by an extra 9 for that 3 times. 3 times is 3 squared. So you get 9v for your other solution right there. All right, oops, bring down, sorry about that. That's it for today. Have a great day, and we will see you next time.